All right, so today is ICS321 Lima, and so this is this class, and today is September 10th, which is this day. So we're into the we're in part 2 of chapter 4, 3 parts. And so let's see what that section is. It must be the sections. Let me see. Chapter 4. Let me view 2-page scrolling. So we discussed already restrict, project, taking the product, gone through these things, and restrict, project, and this is the end of section 1, exercises 1, and then we continue on and we cover union, intersection, and difference. I guess that's today. I guess today we're doing union, intersection, and difference. And we introduce rename because it's appropriate, because we want to treat certain attributes as though they're the same as other attributes. And this is the end of section 2. And then there is a section 3, which is join. Oh, we get into join in this chapter. Well, that's good. And Cartesian product. And then talk a little bit about some of these relational comparisons. And that's exercises 3. Okay, so we're doing exercises 2. So let's, do I have some slides around here someplace? I don't think I have any on this computer, but I know that there are some here. Wait a second, I bet you I've got some in downloads, maybe? Chapter 4. I bet you this is it. Yeah. Okay, so we've covered these. We looked at this last time. This, if you think of this as a table, this depicts rows, and when we restrict, we say we want that table except for some rows. And then project, we say, well, we want that table, but we only want these columns. We don't need the other columns. And the whole idea is when you do this, the project, which is important, is that you end up with a relation. So you do an operation on a relation, and the result is a relation. So that means it's closed. That means that you can nest. That means you can have parentheses, and you can have, if you have two relations and you got some operator in between, those relations can be relations as we know them, or they can be expressions which produce relations. And because we can do that, the reason we can do that is because of closure, so that's important. Product, we just take the cross product. We take a combination of all of the tuples in this one with all the tuples in this one. So the number that you end up with is the number of tuples in here times the number of tuples here, because That's like the cross product of them, all combinations. But then also the size of the tuples are actually where they're, the two tuples are appended to each other. They're concatenated. So this, it's just, so this is, you can depict it this way. There's 6 rows and, twice as many columns. And so today, I guess we're going to talk about intersection, union, and difference. And so this is a good way of illustrating that, where you take 2 tables and you take the tuples that are common in both tables, and that's the intersection. If you take all the tuples that are in either, then that's what union is. And difference is when you take the ones in common in both, just like intersection, except for you remove those tuples from the first operand, and that gives the difference. One requirement is that these these are operations on two relations. Okay, this is just an operation on one relation. This is just an operation on one relation. This is an operation on two relations, but there's no requirement for if the types are the same or if the headers are the same. These are operations on two relations, but their headers have to be exactly the same. So they have to be of the same type. Natural join is like product, except for you only match up the tuples where there's a particular column or attribute that's common in both, and the value is the same for both those attributes. We'll get to that on Wednesday. So let's see where we talk about. We might have already talked about union. Yeah, we covered this last time, didn't we? Union, where this is a projection of suppliers. It's just the cities, and this is a projection of parts, just the cities. So we have a rel var and an operator and a rel var, and they're of the same type. The rel vars are the same type. So you can do a union on them, and this will take take the union of them, which is all the cities, but it'll get rid of the duplicates. And intersection is same thing. You find the cities that are in common to both of them, and that's this. There won't be any duplicates. And this points out that it doesn't matter the order of the attributes, just if they are the same. Difference is where you find the tuples that are in common, and you subtract them out of the first rel var, and that's the result. And again, they don't have to be, the attributes don't have to be in any kind of order. Okay? That's pretty straightforward. So, if we look at the quiz, if you look at the, there aren't any exercises. We have a formal reason for prohibiting duplicate tuples relation. But can you think of a pragmatic? Yeah, okay, yeah, I think we covered all these. What do the following expressions denote? What do they denote? You can assume that projection has a higher precedence than other relational operators. So this denotes, this is all the PNOs, just the column of PNOs, all 1, 2, 3, 4, 5, 6. This is, well, what's this? Well, first of all, this is just a bunch, this is a column of PNOs. We know that. Whatever this is, it's, presumably there'll be a PNO in there. Oh, yes, there will be, because it's SP. There's a PNO in SP. So we're taking all the SPs where SNO is equal to 2, and we're just taking the PNOs and we're subtracting those out of the full set of PNOs. So what we have here is the part numbers that that the second supplier is not shipping. So if we actually try to find one of our, here we go. So we're talking about the SP table, and we are taking the SPs where SNO is equal to S2, so that would be this one and this one. So these would be these two. Those are the S2. So it's P1 and P2. Okay. So that's SP where SNO is equal to P2, or SNO is equal to S2. It's those two. But we only want the PNOs. We're just doing a projection. We only want the PNOs. So this side is going to be P1 and P2. And this side is going to be P1, P2, P3, P4, P5, P6. Like this. Just those. And so it's these minus these, and we end up with P3, P4, P5, P6. So this one, parentheses, first we do figure out this, and then we union it with this. So, by gosh, this better produce just a column of cities. And it does, because it takes the cities out of suppliers and takes the cities out of parts, and it takes the intersection of them, so it's the cities that are common in both. And then it unions it with all the cities in P. It seems like that's... Yeah, I know. I think this is like demonstrating something like the unity operator or some crazy thing. Okay. Anyway, so so you get the idea. Here we are doing a. Well, let's see what the answer to that is. 3, 4, 5, 6. Oh, I guess we don't have the answers here. Do we? No. Well, he explains the answers in the text, or in the book, or in the video. Let me see what he's trying to. I think it's like the identity operator for P or something like that is what it is. Oh, I know where we find out. We are in chapter. This is chapter 1. Okay, let's go back to chapter 4. And it's exercises 2. Oop, I didn't mean to do that. Where am I? Oh, here we go. These are questions. Oh, we just continue the number? Yeah, we do. Oh yeah, 46A. So what does it say for 46A? Part numbers, okay. 46B. Or wait, which one was the weird one? B was the weird one. So it says all parts cities. The expression overall reduces to just P of city. Yeah, of course it does. No, this exercise illustrates one of the so-called absorption laws, which for the record, I spell out here. Okay, so these are the absorption laws. Yeah, right. It's like in logic design when you're designing gates using gates and flip-flops. If you do 331. So anyway, it doesn't matter what you have here. If you union it with R2, you end up with R2. And if you intersect it with, oh wait, no, that's not. Well, anyway, is this, are they? Okay, well, I can't think of an example of how this is useful, but but anyway, so let's look at that last. Let's look at this last one here where we have a restriction. So this is a city. What is D? I can't remember. Let's see. This is D, which is. D union here. Where is that? Are these different? Yeah. I can't remember what D union. Does anybody remember what D union is? D. Oh, it includes the duplicates, I bet. I bet it includes the duplicates. D union. D union stands for disjoint union. Oh, I'm sorry. Disjoint union is like a regular union, except that its original relations are required to have no tuples in common. Otherwise, an exception is raised. Okay, distinct. So each of them is required to have no tuples. It's two disjoint. It's two disjoint relations that are of the same type. So when you do a union of two disjoint relvars, the number of tuples when you're done is going to be the number of tuples in the first one plus the number of tuples in the second one. In other words, there are none in common. Okay, well, anyway, so let's go take a look at quiz 5. No, are we on quiz? We're on quiz 6 now, right? Yeah. Okay, so imagine you have a relation that looks like this, and we have two relvars. One looks like this, and the other one looks like this. That's kind of weird. What is the result of the following tutorial D expression? Okay, so we're talking about cities. We got a set of cities over here, or we have a relvar with a bunch of cities in it that are tuples, and then same thing here. And so we take the ones in common and we subtract them out of the first one, and that's the result. The left one is employees were branches H. Yeah, okay, here. So it's the first three. So if we're talking about cities, it's Honolulu, Aiea, and Honolulu. And then we minus out the employees where the branch is equal to E, and that'd be Aiea, I bet. Oh yeah, here we go. Aiea. Okay, so that removes Aiea. So out of that first one, which is Honolulu and Aiea. So we're just taking Aiea out of Honolulu and Aiea, and we end up with, yeah, okay. So that's pretty easy. Here we're unioning them. Here we're intersecting them, except for it's a little bit different set. Here we're minusing, just like we're minusing here. Here we are minusing, and here we are intersecting. Wow, big deal. Anyway, that looks pretty easy. Just, you know, reinforcing this stuff. So we're learning to think about tables like a rel var is like a variable, and we have expressions, and it's like a programming language. And closure, we have closure, so we can have expressions, and we can have expressions embedded within expressions with these union, intersect, and join operators, and so on. So it's helping us think about, you know, these sets of records, you know, that way. And when we look at what we can do manipulating these tables, we have a bunch of tables, and we want to produce this final table that's a result of some big, huge expression that involves all these tables, and we're joining, and we're intersecting, and so on. You know, you should be thinking about it as, is this just another case where I have to figure out the equation, or I have to figure out the expression or the calculation, just like it's a program. And when you write programs, you can, some of you might write, you know, a variable name equals, and then a big, long, huge expression, because you get into, you know, doing all that in your head. I sometimes used to do that. Or you're someone who just breaks everything down, and you have just a variable operator, variable expressions on the right, and just variables on the left, and you have a whole bunch of temporary variables. So the calculations are very, very straightforward in your mind, and you can follow them, and they're easy it's easy to debug, and so on. It doesn't matter. The compiler is going to make it all the same way anyway. But then when we go over to SQL, the difference is that the operators themselves are different. We do a lot of the restrictions, for example, especially the restrictions. We are thinking about tuples. We're thinking about eliminating tuples. We're thinking about this one rel var and what we're going to do to mess with it inside. Or it's like we have a rel var on the left-hand side of the assignment statement, and the same rel var on the right-hand side of a statement plus like a minus or something. And so we have to make that leap. That's not very It's, you know, when you start getting into the operators, it's not like relational algebra too much at all. But the closure thing is still there. See, that's the important thing. The closure thing is still there. So I learned SQL long before I studied this textbook, and what I got out of it is I'm not afraid now to have a single SQL statement that nests expressions, or it nests SQL statements within SQL statements. So I have this big SQL statement, and I got a parentheses in there, and an SQL statement inside there, and the outer SQL statement just use that as a table, and that it does a select on, or it does joins with something else, and so I think about, see, how could I do this where I don't, you know, because it's tough to have temporary tables in SQL. You know, it's like you're not gonna create an instance of a table and then use it and then delete it. You know, you just kind of don't do that. You try your best to do everything in one expression, and if not, you have a programming language that you do. You know, create temporary relations or create temporary tables, and you operate on those and so on. So anyway, that's the reason for learning this particular language. You know, every database class has a particular sort of theoretical or academic language that it uses to teach the concepts, and tutorial D is this one. And we're getting this restriction concept in there, but it's always sort of embedded inside this idea that of, you know, closure and relations can be, I mean, expressions or you know, can be embedded in other expressions, and so on. So you know, so with that, this one's pretty easy after you sort of know what we're asking, and so that's pretty straightforward, I think. Last time I covered the. I talked about this assignment. Is that what I did last Wednesday, or is it the Wednesday before? Oh, Wednesday before. Okay. All right. Anyway, so I don't really have too much more today, and you know, I guess what you should be doing, and I guess I didn't emphasize it that much, but you know, I kind of loaded up these study.com, you know, fun little quiz exercises in the beginning, so later on we're going to be doing assignments and so on. So I guess that's what you're going to be spending your extra time on, you know, sort of getting those out of the way. If you can just get them all out of the way in the beginning, and then when we start getting into the assignments, I'll start adding stuff on, and we'll have some gap time here at the end for you to finish stuff up. All right. I don't really have anything else. So thanks for watching.